Hello and welcome. This is going to be our help video for Slant Asymptotes. It's just 10 problems, all of them with the same directions. We want to just simplify each and state its excluded values. State the equation of the slant asymptote if there is one. And when we state the excluded values, I want us to be specific on whether those are holes or whether they are vertical asymptotes. All right. Every single one of these problems is going to start with factoring. You need to factor the top and the bottom. The top of this one is going to be x minus 9 and x minus 10 divided by, and then the bottom I can factor a 5 out of both of these. So x minus 9 pops out there. Let's go ahead and cross out our factors that cancel. But we need to still keep track of them because they still impact our excluded values. So although this x minus 9 canceled, we still need to take that x minus 9 and set it equal to 0. Or specifically, we're going to say it cannot equal 0 because then we would be dividing by 0. When I add 9 to both sides, we get that x cannot equal 9. So this is my excluded value, and it's a hole specifically. So specifically a hole in the graph because the factors canceled. Factors canceled. All right, now what remains, so we're trying to simplify it. The simplified form of this is just going to be x minus 10 divided by 5. So that is the simplified form, and then this is also the equation simplified to be a linear equation. So that linear equation is going to also be the equation of our slant asymptote. How did we know this was going to have a slant asymptote? It's because the degree up here is a 2, the degree on the bottom is a 1, and so the degree of the numerator is 1 higher than the degree of the denominator. And those always have slant asymptotes. So here, this is our simplified form. And to get the equation of the slant asymptote, I want to take this and put it into y equals mx plus b. So this would be y equals 1/5 x, that's my slope. And then the b would be negative 10 divided by 5, or minus 2. All right, so that is the slant asymptote. All right, nothing else to do there. We'll skip 2 because I've run out of room. And we'll move on to 3. In 3, right off the bat, we know that this isn't going to have a slant asymptote. The degree of the top is 2, the degree of the bottom is 2, and so when they're the same, then it has a horizontal asymptote. Let's go ahead and factor, though. The top is going to factor into 6 times, actually I can pull out a 6n. They both have an n, so 6n times n plus 10. Accidentally wrote a squared. At the bottom, simple factoring. Set up this structure here. I've asked myself for 2 numbers that multiply to be 40 but add to be 14. Those numbers are 10 and 4. And so you can see we've got 2 factors that cancel. Yeah, n plus 10 cancels with the n plus 10. We're going to take that and say that that cannot equal 0. Subtract 10 from both sides. We get that n cannot equal negative 10, and this is a hole in the graph because it was a factor that canceled over here. N plus 4 cannot equal 0. We subtract 4 from both sides. N cannot equal negative 4, and this here is a vertical asymptote. And the simplified equation would just be what's left after the canceling, 6n over n plus 4. Let's see. We'll move on to the next page. Number 5 looks like a good one. I can tell that this is going to have a slant asymptote. The degree of the top is 1 more than the degree of the bottom. Let's go ahead and factor. Set up your structure. Two numbers that multiply to be 10 but add to be 11 are 10 and 1. Factor 2 out of the bottom, we get 2 times x plus 10. And this is going to cancel with this. X plus 10 cannot equal 0. So subtract 10 from both sides. X cannot equal negative 10. That's a hole in the graph. And what's left is this expression here, x plus 1 over 2. So that's our simplified expression, but the slant asymptote is at y equals 1/2 x plus 1/2. And that just comes from rearranging this into linear form. So this is the simplified, this is the slant asymptote. All right, looking for one that is not going to cancel. Let's mean. Let's just see what's this one. Two numbers that multiply, positive 6 and negative 2. All right, that one, that's our easy case again. Let's see, let's just try these. Two numbers that multiply to be 42 but add to be negative 13. Those are our negative, 1 second, 42 is 7 times 6. Yeah, so negative 7, negative 6. That took me a little longer than I needed to. Factor in a 5 here. Aha. Okay, so this would be a good example of our hard case. So we know this has got a slant asymptote because the 2 is 1 bigger than the 1, but nothing's going to cancel here. So what we have to do is long division. But let's finish writing this out. So this is going to be our simplified form here. Because nothing cancels, we have no other options to simplify it. Yeah, they just leave it like that in the answer key. But we can still get the equation of slant asymptote by doing long division with the polynomials. So here's our refresher in this video on how to do long division with polynomials. So write the top underneath a long division symbol. Write the bottom outside of that long division symbol. Don't use the factored form at all, use the actual standard form. Now I ask myself, x times what equal, or 5x, the biggest term over here, times what equals x squared, the biggest term over here. So, well, if I can't figure it out, I could do x squared divided by 5x and then simplify. That simplifies there to just be 1/5 x. So it's 1/5 x. Then I need to multiply that to both of these terms. So 1/5 x times 5x gives us that x squared. 1/5 x times a negative 15 gives us a negative 3x. Subtract that away, and we'll get those cancel. This becomes a negative 10x. Drop down the 42. 5x times what equals negative 10x? Well, that's just -2. And actually, at this point here, we're going to stop. Because it doesn't matter what the remainder is. We've already figured out the linear and the constant term of the slant asymptote. So we've got a slant asymptote at y equals 1/5 x minus 2. All right. There's still one last thing to do with this one, and that's to state our excluded value. X minus 3, let me do this in a different color. X minus 3 cannot equal 0. Add 3 to both sides. We'll get that x cannot equal 3. This is a factor that didn't cancel, so that's the excluded value. But because it didn't cancel, we have a vertical asymptote at x equals 3. All right. And so that's about all we can say about this equation here with the information so far in this class. So best of luck finishing up the rest of these. I'll see you on Monday.